Hello and welcome back. In today's video, we're diving into the fascinating world of indexing PDF files using Google's latest AI technologies. We'll be walking you through this process step by step so you can follow along or adapt it to your own use case. Our plan involves two main components. First, we'll use Document AI, Google Cloud's flagship service for parsing PDF files and extracting text. We'll be employing a server processor for this task. Later, we might call upon Python to assist us further. Next, we'll harness the power of Gemini and Vertex AI to transform the extracted text data into a useful index. This is enterprise-grade AI we're dealing with, a two-step process that might require some additional Python code to tie everything together. The end result? An index for our content powered by cutting-edge AI models and robust document processing. This index will provide a search-style interface with page numbers, running textual analysis on a page-by-page basis. Let's begin by selecting our book. We'll keep it classical, considering popular downloads like Romeo and Juliet, Moby Dick, or Pride and Prejudice. However, we need to choose something manageable for our demonstration. We'll go with Dracula. After browsing the online version, we can see it's a good length, substantial but not overwhelming. We'll save it as a PDF, which comes out to about 300 pages. This is an ideal size for our purposes. Next, we'll set up Document AI. We'll use a straightforward processor, opting for Document OCR since our content is likely to be complex. We'll name it Indexer and stick with the default settings. For a quick test, we'll focus on just the first dozen pages to show how it handles both body text and stylized elements like the title. An important tip. Throughout this process, we'll need to strip out header and footer text. These typically aren't useful for indexing, so we'll pre-process our text to remove them. To take our document AI processing to the next level, we'll introduce Python. A comprehensive approach would use Vertex AI Workbench, Google Cloud's featured Jupyter Notebook service. While we're setting that up, let's create a cloud storage bucket to hold our PDF and any other files we might need. The default settings should suffice, and adding content is as simple as drag and drop. Now let's return to the Vertex AI Workbench service. We don't need any special configurations or GPUs for this task. To keep costs down, we'll minimize the machine type, bringing it to about 12 cents per hour. Unfortunately, we hit a snag with the initial instance creation, so we'll pivot to using a user-managed notebook. While this isn't typically the first choice, it should work well for our purposes today. We'll opt for a basic Python environment without any need for CUDA or other special configurations. We'll run this in US Central 1. Once our Python environment is up and running, we'll install the necessary Google Cloud libraries. It turns out Document AI is already installed, so we'll just quiet down the installation process with a flag. Next, we'll focus on the document processing code, referencing Google Cloud's documentation for guidance. We'll analyze the Python samples provided and adapt the code for our Jupyter notebook. The key components here are the Google Cloud Document AI and Google Cloud Storage packages. We'll need to install the storage package if it's not already present. Now, let's configure our processor. We'll use the document OCR processor we set up earlier. You can find its ID on the processor's page. We'll also need to specify our storage bucket name, which in this case is indexing PDFs. Don't forget to select the most recent version of the processor. In our case, it's from last June. We'll set up the code to process our PDF, specifying the correct MIME type and the full path, the cloud storage URI, to our file in the storage bucket. Importantly, we want both the text and the page number, so we'll use the suggested field mask. Despite some verbose comments, the main function is straightforward. It processes the document and outputs the results to files in Google Cloud Storage. As we're working with the single large function, we'll declare it explicitly and set up our constants and imports. After a few moments, our output is ready. We now have a handy document object containing all the text for our analysis. The results are in a clean JSON format. To keep our workspace tidy, we'll clear the output cell of excess text. Let's examine our cloud storage bucket where our input and output files reside. We see our original PDF file along with the output, about 33 distinct JSON files. Given our PDF was around 300 pages, each JSON file likely contains about 10 pages worth of text. Now comes the exciting part, using our document object to extract page numbers and aggregate content across pages. This will provide our large language model with context spanning multiple pages. As we move forward with our page-centric collection of text, we're carefully weeding out unnecessary elements like the book title, link, certain page numbers, and dates. This process ensures we're only working with the most relevant content for our index. However, we've hit a small hurdle. Our initial processing only handles a single JSON file, but we have 33 files to work through. Let's adjust our approach to process all of these files sequentially. After making these adjustments, our processing seems to be progressing nicely. But we've encountered another issue. All our pages are currently coming up blank. This suggests we might need to revisit how we're accessing the text within our document structure. Let's dive deeper into exploring this data structure. We'll focus on the first 2 pages, examining the first 2 blocks on each page, and printing out the first 2 paragraphs from those blocks. This should give us a clearer picture of what's happening. It turns out that dealing with these JSON files is a bit trickier than we initially thought. Instead of using blocks, we need to reference the text differently. We'll pivot to using lines instead of blocks to access our content. After making this change, we're in a much better place. We're now getting a nice balance between the text and formatting.
Searching through the pages, AI at its best. Get those models going, we keeping it fresh. Organizing data, yeah, it's nothing complex, cause it's LLMs. OMG, here we go. Yeah, cause it's LLMs. OMG, here we go. It's an AI-based index, that groove you know. It's an AI-based index, we rock the show. It's an AI-based index, done like a pro. It's an AI-based index, come on, let's go.
Now that we've got our text extracted and cleaned up, it's time to generate keywords. We'll use our large language model to analyze the text and produce relevant keywords for each section of the book. There's a small error towards the end of our processing that we'll need to investigate, but overall, this is shaping up nicely. The results are looking promising. We're getting some great keywords that seem highly relevant to Dracula. Let's review the beginning and end of our keyword list to make sure everything looks correct. Based on the structure of the output, it looks like we'll have about 33 different keyword lists for different parts of the book. To finalize our index, we'll use a bit of Python to combine all these keyword lists into a single output. It appears we have a couple of pages that didn't generate keyword results, but otherwise this looks great. After this processing, we've got a much better result. We now have our keywords for the entire book grouped by page number. This is an excellent output for further analysis or for use as an index. As we wrap up, it's worth noting that this process we've developed is quite powerful. We've taken a complex PDF document, extracted and cleaned its text, and then used advanced AI to generate a meaningful index. This technique could be applied to all sorts of documents, from classic literature like Dracula to technical manuals or academic papers. Thank you very much for watching, and we'll keep an eye on the comment section for any questions. Of course, we'll also include the Jupyter notebook and diagram file in the video description. Please enjoy responsibly.